sparkling swimming pool is a thing of beauty, but just ask any pool owner and they'll tell you that keeping a pool clean is not that easy. So just imagine how much work is needed to keep an Olympic-sized pool clean, like the one at the Canada Games Aquatic Centre. For the last 20 years, Grant Murphy has been one of the people who's looked after the inner workings of the city's swimming pools, and he has to make a lot of water sparkle 365 days a year.
This pool here has just shy of 1 million gallons of water. Usually a backyard swimming pool could have between 10,000 to 20,000 gallons. This one, like I said, just about 1 million. This pool is a 50-meter Olympic-sized swimming pool with a deep end to be roughly about 5 meters, a little bit over 16 feet deep.
As the hole was dug to accommodate 1 million gallons of water, the excavated dirt was used to create the rolling landscape surrounding the Aquatic Centre. The facility is used for a number of local and national events, and everyone who comes to swim just expects the pool to be safe and clean.
Well, people expect obviously a clean environment that they can come, enjoy, have a good time, and leave being healthy at the end of the day. We have approximately on an average day about 1,200 people that come through the building. During a large event, that could go up to 3,000 to 4,000 people a day. So between when the facility opened and when we did a renovation in 2014, we estimated about 8.5 million users.
It's a heavily used pool, and with that you need a filtration system that will clean it quickly, efficiently, and make it safe for all the bathers.
But you also have to keep the water fresh, which means replacing a lot of it every day.
We have to dump 20 liters per day per bather per health regulations, so we could use quite a bit of water per day. You could be looking 4, 5, up to 7,000 gallons a day that we have to get rid of. And when you get rid of the water, you have to introduce it with more potable water, city water. When people come in, they don't want to see a fuzzy, not good-looking pool. You want to see a nice, clear pool where you can see down to the bottom. And, you need a system that can handle that.
We have our earliest swimmers are here at 5:30 in the morning, and our last ones get out of the pool at 10 p.m. So our challenge is obviously making sure that whenever, at what point during the day you come, that the facility is clean, it's welcoming. So yeah, there's a lot that goes on. We do most of our deep cleaning, I guess you could say, overnight. So there's someone in the building 24 hours a day. But our operations staff is constantly checking in with the filtration systems and the sanitation all the time. And it obviously runs nonstop.
Well, let's go down to the basement and we can see the inner workings of how a pool operates.
Beneath the surface and behind a wall of concrete is where the real cleaning happens. Motors squeal and pressure builds as the pool's water passes through a network of pipes and pumps.
That you hear is the high-pitched sound of the winding of the motor in its variable speed pumps that will basically run the pool gallons per minute to about 2,700 gallons a minute. And they ramp up and down to what the filter needs.
The pool's first line of defense is the same thing you'd find in a backyard version, a strainer. However, at the Aquatic Centre, they are much larger and capture a different kind of debris.
And you do get a lot of debris. If we didn't have one of these, all this would be going through the impeller and these pumps wouldn't last very long at all. We have one for each of these pumps. They're quite large too. And it comes in and basically stops it all from here like you would see in your home pool. Everybody should have one on their home pool. It's a little bit more of a process to clean these out. That's why, and they also holds a larger amount of it. So that's why we only have to do it really every couple of weeks to a month, depending on how much usage we get in the pool. We have to take it out, power wash it all, clean them all off, scrub them with scrub brushes. At your home pool, you would take yours, knock it out, and that would be it. You'd be done. Now, how a swimming pool should operate is basically a 60-40 split. So you want 60%, between 60 and 70% of your water that you want to get into the filter off the top part. It's gutter water. And then the other 30 to 40% from your main drain water. The dirtiest part of a swimming pool is probably 6 to 12 inches of the pool is the dirtiest part. It floats, a lot of stuff floats, comes into the gutters, into the surge tank. We want to take that first, or as quickly as we can.
Once the water passes through the strainers, it heads to the filter. But this is not like your backyard filter. This system relies on a form of powder that catches even the tiniest particles of debris.
These are the best filters on the market. They filter down to basically 1 micron. Bacteria is 1 micron. So if you look at it from this way, human hair is 70 microns. And these will filter down to 1 micron. That's quite a bit of filtration in these. They're the newest ones. As you look, the water will come down, pass through the bottom of these filters, go through these little tubes that are inside, and what's on the tubes is a filter cake or a powder that we put into the tank that traps around the tubes, and that's what filters out any kind of debris, anything that gets past the hair and lint strainers. What I'm going to do is I'll push this button and we'll put it in what's called a regeneration. And what you'll hear is an air release. There's a plate up there that these tubes are held onto, and what that does is air is placed into a bladder on the top of the filter, depresses it, shakes the tubes, allowing all this filter cake or powder to come off. And then our compressor will recharge the bladder that's on the top of this. So you'll hear the pump ramp down, get some banging a little bit. You'll see all the powder will come off. It goes into a solution. Once it's loosened it all off with the plate and the air compressor, then it will reattach it with a recirculation motion, which basically puts them on a little looser. As it's running throughout a few days, it becomes very tight on those filter tubes in there, which reduces the amount of filtration a bit. Anything that comes in the filter, pick it up. In a normal home swimming pool with a sand filter, you may have to backwash it every week. Here we can get away with a few months of a backwash, which helps to reduce the water load on the building. We're not using as much water. Each one of these tanks holds about 640 gallons. The old filters we had in here before the renovation, you would use on a backwash about 12,000 gallons per filter. Here, you're looking about 640 gallons.
After it's been filtered, the water enters the UV system, where anything left over is obliterated. The lights in the chamber are blinding, like looking into the sun.
It's so bright you couldn't even look into there. UV, it's just so bright that it basically will destroy anything passing through there. It just will zap it. Well, there's large, intense UV lights. There's tubes that are in here, like you would a UV system. Large tubes, very, very bright in there. Kills any kind of organism, bacteria, anything that may pass through the filter. As it heads back out from the UV, and its chlorine is introduced, that water right there is as pure as it can get. When it gets back out into the swimming pool, obviously it gets contaminated in the swimming pool. We bring it back in and repeat the process.
Before the water goes back into the pool, it needs to be heated. The heater is not what you would expect. It's a small box filled with metal plates where the water is squeezed through a tight honeycomb-like network to reach its desired temperature. The pool is always set at 82 degrees Fahrenheit.
What's underneath here is it's a bunch of little plates, and the hot water and pool water are in between these plates. So you have hot water, then pool water, hot water, then pool water. They don't meet. They just draw. The pool water will draw the hot boiler water out and back into the pool system, out to the swimming pool. When you got pool water and hot water from our boilers together, it just absorbs it right into the pool water. They don't touch. They don't touch, but they're in plates that absorb it. So you're picking up the same amount of heat that's from the boiler back into the pool water, back out to the swimming pool. It's quite efficient.
The Aquatics Center is always looking at being as energy efficient as possible and recently introduced a new system to help heat the pool and the building.
So this is our cogen facility. Basically what you have are 3 natural gas generators, and they burn natural gas, generate electricity from that. And then you can see the white tubing is tying it back into the heating system of the building. So the heat from the burning process supplements or eliminates the heat needed from the boilers. So we can turn back the boilers in the building and use the heat from generating electricity to heat the pool, heat the water. And yes, it's much less wasteful than just burning gas to create heat.
This is just a mechanical office that we use.
Technology also plays a big part in monitoring the condition of the water and helps the technicians stay on top of any issues that might arise.
This is the pool heating system. This tells us what's going, if all the pumps are working right, the temperatures. This also tells us what the temperature of the spa is, make sure that the pumps are working okay, the amps that they're drawing. Basically allows us to know. It comes through our cell phones, our smartphones also, and it allows us to see how the pools are running and how the HVAC systems are running. And to know if something's off or something's not working, we could also retrieve that from our smartphones, which makes it more efficient. If there was a problem, we can get on it right away. And if we notice that the temperatures have dropped, we may know that there's been a power outage. Also, it helps to go, oh, something's not right here, we've got something going on.
The facility also upgraded its lighting system to save energy and time.
This is the top of our service catwalk. It's so we can access our lighting fixtures without having to put in lifts in the building. Before we put this in, we had to have tall lifts, which made it very difficult for us to change lighting throughout the calendar year unless we were closed. So now if we have any dead bulbs or LED strips, and I guess as it were, we can replace them anytime. The building is kept at about 88 Fahrenheit, so no, it's always heated. In the summer, we just don't cool it as much. So it's kept so that it's comfortable for people who are obviously in a bathing suit on the pool deck. Now we're at the top of the building, so it's one of the hottest points, and plus we're close to the lighting, which obviously is not hot, but produces some heat.
The last step before re-entering the pool is to have chlorine added, but unlike the giant jugs you pour into backyard pools, the chlorine here is added in a gaseous form.
Well, what this system does is when it's calling for chlorine, it will turn on this pump here. This pump will pass water through this little device up here, which is called a venturi. This here is gas chlorine. Now what it'll do is when the pump comes on, it goes through a little venturi. It will suck the chlorine up through our 150-pound cylinders, introduce it into the water. We use gas chlorine here. Gas chlorine is 100% active chlorine. And if you look at liquid chlorine or sodium hypochlorite, it could only be 12 to 15% active. For a larger pool like this, we need a quick response from chlorine, which gas chlorine gives it to us quite quickly.
Chlorine keeps the pool free of bacteria, but it's not the only chemical added. To maintain the proper pH levels and clarity, more chemicals are needed daily.
What we have is sodium bicarbonate, which is a baking soda, and it gets put into the pool weekly to maintain a proper pH balance. Well, it's usually about 200 pounds, 200 to 300 pounds a week that is added in. If you take a bag, one of these 25 kilogram bags, and you use it for your home pool, it will probably last you a few years. Here, it only lasts a day or two because there's so much water in this pool versus a backyard swimming pool. So it's just part of the chemical process that's added into the swimming pools every day, every week.
A lot goes into keeping 1 million gallons of water clean and clear, but the staff at the Canada Games Aquatic Centre is always making sure everyone who comes to use the pool leaves happy and healthy.
Well, we look at it as, would I put my own family in this swimming pool? And that's the way we approach a job every day. And just making sure it's safe, and when we leave, we're comfortable that everything's working as perfect as it can possibly work. And if we leave and we're satisfied, we're okay with people using the pool.
Just like a pool, there's a lot more to maintaining an ice rink than just freezing water, and Nichols Arena has to upkeep 3 ice pads year-round.
They expect a clean facility. They expect a safe facility. Obviously, ice conditions are our number one priority, and to have a good time and enjoy themselves while they're here.
Being a multi-purpose facility, Nichols Arena has a lot of patrons to please.
So we have people counters installed at all of our facilities, and roughly 30 to 40,000 people per month come and go through Nichols Arena.
So how does the arena keep up with the constant demand?
But yeah, around the clock we have staff working on the ice. We flood every hour in between rentals, or more if needed. And yeah, like I said, the ice conditions are paramount for us.
Enter Bruce Matthews. He's been working in arenas for over 20 years. He maintains, monitors, and repairs the rinks every day. There are a lot of factors that make a good ice pad that can't be seen by just looking at the ice. Every 2 hours, Bruce has to go back to the compressor room where he can get some in-depth information on the ice conditions.
Come on in. So what we're doing now is we're in the compressor room. We're just going to be doing our daily readings that we have to do every 2 hours. Let us know how the refrigeration equipment is working. This computer system, we can pretty much change any temperature of the ice we want at any time of the day. And it also gives us information on how the system is working. Right now this shows the whole room. It shows all our compressors here. We have 6. 2 are for the C pad, which are running right now. The other 4 are for the A and B rinks, which were original compressors here. It'll tell us our ice temperature, what systems are running right now. We have our condenser on the roof. It's basically a snapshot of the whole room itself. It gives us an idea. It'll also give us warnings if something isn't working, and we can come in and check. So I'll just go ahead and write the ice temperatures down. Our ice temperature is usually around 21, 22. Right now, because we have someone doing a flood right now, our temperature has risen up, which has caused the compressors to come on. We can do each arena snapshot itself. What we have is infrared cameras up in the ice, or in the ceiling, sorry. It'll take the surface temperature, so as soon as the Zamboni passes it and puts water down on the ice, it tells the system that the temperature has risen up and that we'll have to start cooling it down again, which will turn the compressors on. So, or we can do it the old-fashioned way and do the slab temperature. We find this is a little energy efficient. So we do it that way instead.
After recording the computer data, it's time to make sure the machines are operating properly.
Okay, so that's pretty much it for the computer system. Now we go around and do our manual readings.
The machines are pivotal to maintaining a consistent ice temperature, but it also depends on two main chemicals, glycol and ammonia. Glycol removes the heat from the ice, and the ammonia in turn removes the heat collected by the glycol.
This is the glycol. This is our secondary refrigerant, which actually runs underneath the ring surface. It attracts all the heat, brings it back in here for cooling, and then goes back out again. Temperature difference usually about 4 degrees. So right now it's coming in at 18 and coming down back out at 17, so it's working its way slowly down. This is a plate and frame, and what it does is the glycol runs through here as well as the ammonia gas, or liquid, sorry, and they don't touch each other. They run side by side. The glycol gives off its heat to the ammonia, cools down, goes back out and gets more heat from the refrigerant, or from the ice surface. What it is basically just fins, and every other one's ammonia, one's glycol. They just pass, the glycol gives off its heat to the ammonia, goes back cooler, gets more heat, brings it back in. You can picture under here is the heat exchanger, so underneath this plate, each plate giving off heat to the cold ammonia. That's why we get the frost on there. It usually won't get much worse than this, and it's a complete melt and freeze cycle, depending on the amount of use it gets. So now we'll go over to the compressors. Down here is our crankcase where we can actually see the oil in the compressor. As long as we're in this slate glass small circle, we're good. The compressor is taking the ammonia, changing its state, so it's sucking it in from the condenser, changing its state, pushing it back out as a high pressure liquid, and coming back in again. It's just a continuous cycle. So when the ammonia is up in the condenser, it's got all its heat, it has to come back down, compress, go back up again. It'll absorb the heat from the glycol. The ammonia goes up into the condenser. And all these pipes go up to the roof. Water and air cool the ammonia, changes it from a vapor to a gas, brings it back down to absorb more heat.
After a thorough check in the compressor room, it's time to hit the ice and take some more measurements.
So we'll put the helmets on in case we fall on the ice. That ice is very hard. We don't want to get a concussion or even worse. We also have cleats that we have to wear so we don't slip. They just have little spikes on there, gives better traction on the ice. So what we're going to do is we're just going to check the ice thickness right now. We have 23 spots we have to check on a weekly basis. Basically, we just use a drill and a tape measure. One drills, one records the thickness. What we do is we just measure the depth, mark it with our finger, and then use a tape measure to record so we're at 1.5 inches right now. That's right where we want to be. Depending on the usage of the day, some areas will be less than the corners. The corners are usually built up higher because of the way the floods are done and all the water is swishing over to the corners. The center ice is probably a little lower. Creases are definitely going to be a little lower than 1.5 inches. In an ideal world, they'd all be 1.5 inches, but it's the nature of the game. Quarter?
Inch and 1/8.
Obviously this area is where most of the game gets played, so it's going to be a little lower than say the corners are. So this is the area we'll have to concentrate on building it up. We'll either come out and just do a couple normal floods, or we'll come out and we'll just soak the water to it. and just do it as fast as we can. Drop the water down, let it freeze, get back out here right away, and repeat the process again.
After all the checks are done, it's time to do some physical alterations to the ice to keep it smooth and even from end to end.
So we'll go out to the rink and edge the ice. We started using electric edgers about 2 or 3 years ago for air quality in the rinks. Basically all they are is battery operated. They have 8 cutting blades on the bottom of them on a disc that rotates. These are your cutting blades here. Basically they are as a little square, and each edge of the blade or the square is a cutting blade. So we can get 8 times out of these blades by rotating them and then flipping them when we have to sharpen them out. Normal marine deep cycle batteries that we keep charged all the time. And they're more energy efficient than using gas, cleaner air, and they work actually really well. So we'll turn it on. We'll lower the blades to the ice. It's got a safety switch here. If we were to let go, or if we were to slip, if we let go of this, everything would shut down just like your lawnmower at home. There it is turning. So now I'll turn the blade down, touch the ice surface, and we'll start cutting the ice down. So what we'll do now is we'll chop the ice. We've edged it down, got some buildup along the boards. We'll use the chopper, and we'll just walk around the rink and chop it all down. Yeah, we usually do this once a day. And now we've edged it and we've chopped it. Now we're ready to take the machine out and do a flood. So now we've got all the ice preparation done. We'll go out and get the ice ready for tonight. The things that keep me coming back every day are the people, the variety of the job, seeing the kids' faces when they're playing, scoring a goal. The little Timbit guys are hilarious to watch. Sometimes the shirts are bigger than they are. You just see 2 skates coming out, so stuff like that.
Well, I've been here, like I said, since 1994, so it's changed quite a bit since then. So it's been really neat to see the changes over the years, and basically grow up with the staff. Like I've known these guys for the same amount of time, so it's a fun place to be. We enjoy it here. We take a lot of pride in our work. So yeah.
I've been at Nichols now for almost 15 years. I originally started here back in the 80s, took a break, went to different arenas. And when the expansion of this Nichols arena happened, I came back here and been here ever since. Things that make me happy going home are knowing that people are going to be using the facility that I help maintain. They're going to have fun, they're going to enjoy it, it's always going to be here. There's just things that people want to come to the recreation department facilities. It's something they want to do. It's not something they have to go and be mad about having to pay a bill or a car repair. It's something they want to do. They want to be here, and you can see that in the people when they're watching their kids play. And then to be doing it as long as I have, to actually see people going from Timbits hockey, now playing midget hockey. You get to know the people over the years, and it's just interesting to see them coming back year after year.